Hello everyone, welcome back to Cooking Simulator tutorial. If you'd like to support the channel, you can purchase the assets from the previous video by link in the description, and you will be able to use them in all your projects. And in this video we will create a burger, and in the next video we will add the support for additional features including burger interaction with plates and recipes. First, let's create a class inherited from BP food item and name it BP complex food item. This class will serve a general description of food items that can store other food items inside. We'll describe this class in more details later. Open it and add the BPI dish interface. Then close it. Next, create a class inherited from BP complex food item and name it BP burger. Open BP burger, and for the mesh, select burger bun bottom and another static mesh named top, and for that mesh select burger bun top and place top mesh to make it look well. For burger we will create something like a food items whitelist, where we define which food items can be added to the burger and the required state of those items. To do this, add a variable called allowed food items as the map, with DA food item BP as the key and BPE food item state as the value. We created the variable, but we missed the main ingredient of burgers, the meat. The meat needs to be cooked, specifically fried or grilled. For simplicity, we will make it fried. So let's add a new state BPE food item states called fried. To support this new state, update DA food item BP. Add a variable called fried mesh of type static mesh. Next, let's create a food item asset. Open the Assets Food Items folder and create a data asset of type DA food item BP and name it food item meat. Open the newly created asset and add the following meshes. For default, add SM meat. For half slice, sliced and on plate, set the mesh to raw burger. For fried, add the fried mesh. Lastly, set the icon to C meat. Next, open BP burger and add fried meat to allowed food items map. Next, let's implement try add item. First, get food item asset from food item. Check if the item exists in allowed food items map. And if the state of the current food item matches the required state. If any of those conditions aren't met, return false. To make the check reusable, collapse it into a Q function. With input food item. Name the function is food item allowed. To avoid duplicating the same logic as in kitchenware, and in case you want to create another food item that can hold other items inside, it's useful to create a simple actor component to handle this functionality. This component will just store information about added food items. That's why open the blueprints folder and then add a new folder called components. Next, inside the components folder, create an actor component and name it AC Food Storage. After that, open it and implement the BPI dish interface. Now let's create two variables. The first one is items, an array of type BP food item. And the second is max food items count, which is an integer. Next, add a new function called hasPlace. For the input, create a variable called newItemsAmount of type integer and set its default value to 1. This will help us reuse the function later when we need to add multiple items at once. That function will return boolean. Inside the function, check if max food items count minus the length of items is greater than or equal to new items amount. By this way, we can determine if there is enough space for new items. Let's implement the try@item function. First, check if there is space for one item using the hasPlace function. If there is no space, return false. If it returns true, add the item to the items array and return true. Next, let's implement the try@items function. At the start, check if there is enough space for the items by using the length of new items as the new items amount. If there is enough space, append the new items to the current items array and return true. If not, return false. Now open BP plate copy the getIngredients function and paste it into AC Food Storage. Finally, add a custom event called destroy and destroy every item in the items array. Now let's update the kitchenware by adding the food storage component. Don't forget to update the max items count of the food storage. Inside the try@item function, use the try@item function from the storage component. If the item is added, attach it to the food place and call move to place for the item. Then return true. To avoid duplications in future, collapse the attach actor to component and move to place nodes into a new function named attach food item. Make sure that food item has an input of this function. Next, add a new function called getFoodItems. Make this function pure and return the items from the food storage. Then add another function called clearFoodItems, where you will clear the food items from the storage. Update the arrays inside the isEmpty function by using getFoodItems function. Next, we need to replace every usage of items array in kitchenware classes with the getFoodItems function. To do this faster, use find references by class member all to locate all usages. For the onDestroy event, replace everything with the destroy function from the food storage component. Inside BP plate, replace the body of getIngredients with food storage's getIngredients. Update hasPlace by using hasPlace function from food storage. Add an input variable called newItemsAmount of type integer and set its default value to 1. Inside try@items, call the try@items function of food storage, instead of check if there enough space. Next, update the for each cycle body and replace the try@item call with attach food item. Inside try_grab function, in places where we call try@item, use getFoodItems function. And in places where we clear the array, use clear food items. Lastly, we need to update cookware. Replace every reference to the items array with getFoodItems. Once there are no remaining references, delete the max food items count and items variables. Finally, move isEmpty, attach food item, get food items, and clear food items into the dish category. After our update, we can move forward. Open BP complex food item and add the food storage component. In the tried item and tried items functions, simply call the corresponding function from the food storage component. Next, in the begin play event, bind an onDestroyed event handler. Inside the onDestroyed event, call the destroy function of the food storage to destroy the stored items. Now we just need to open BP burger and continue implementing try@item function. Call the parent's try@item function. If a food item is added, we need to properly attach it. By this I mean we have to attach the item to a special place and move the food item to a specific position. To do this, open BP grabbable, find the move to place event, and add an input called target relative position of type vector. Next, open BP burger again. In the try@item function, if item wasn't added, return false. If the item was added, attach the food item to the root component. Setting all attachment rules to snap to target. We need to place the item on top of the existing items. To do this, use the relative position of top bun. Specifically, we will use only that value. pass this value as a Z position in the move-to-place function of the food item. Next, we need to raise the top bun. Adjust its location based on the height of the added food item. To get the food item's height, call getComponentsBounds on the food item's mesh. Multiply that value by 2 and add this value to the current Z position of the top bun. Finally, use the updated Z value in the setRelative location for the top. Keep the X and Y values the same as the current relative location. After this, return true. Let's collapse all nodes starting from attached to component to setRelative location. Into a function called attachFoodItem. That function should be with an input food item of type BPFoodItem. Next, let's implement the triedItems function. First, we'll check if the items are allowed. Use a for each loop to iterate through the items. For each item, check if it's allowed. If any item isn't allowed, return false. When the loop is completed, call the triedItems function from the parents class. If the items weren't added, return false. If the items were added, call another for each loop and attach every food item using the attachFoodItem function. Once this loop is completed, return true. Also select the food storage and set 4 as the max food items count. Next, we need to create a data asset for the burger bun as a specific food item. To do this, open DA food item BP and add a field named food item class, which will be a class reference to BP food item. Now let's update BP food box. In the grab-drop event, set the food item class from the selected food item asset as a class for the spawn actor function. Next, open BP food item and change the set state event. Set the fried mesh when the state is fried. And collapse that logic into a function named setMeshByState. Open the setMeshByState function. Inside, check if the selected mesh is valid. If it is, update the mesh. Finally, use the setMeshByState function in the beginPlay event to ensure the mesh is updated correctly at start. Before we can add the meat to the burger, we need to fry it. While we already have a cooking process in BP Cookware, We haven't implemented state changes yet. Let's fix that. First open BP cookware and add a new event called onCooked. Next, inside the update cooking progress function, when the cooking process is finished, call the onCooked event. Now create a new class inherited from BP cookware and name it BP.pan. In BP.pan, implement the onCooked event, inside this event, apply the fried state to the every food item. Now we can fry the meat, but we still can't grab a food item along with the burger bun. Open BP kitchenware and go to the try add item function. At the start of the function, check if the food item implements the BP addition interface and if kitchenware isn't empty. If either of these conditions is false, the function should continue working as it did before. However, if both conditions are true, it means the food item can hold other food items inside. Call try add items of food item, and pass all the food items from the kitchenware to the function. If the food items are successfully added, clear the food items from the kitchenware and return false. If the food items weren't added, just return false. Next, let's create the burger bun food item data asset. Go to Assets Food Items and create a new data asset of type DA food item BP. Name it food item burger bun. Open the data asset and set the burger bun as icon. And set BP burger bun as a class. We don't need to set any meshes here. Lastly, open the level and add 2 food boxes. One with burger bun and another with a meat. Also change the default item on the stove to BP.pan. Now let's check how it works. Everything works well. In the next video we will add more ingredients to the burger and complete the recipe. Thank you for your attention and see you soon!